anyway, but welcome everybody to the first session of the third day of ICPE 2021. So my name is Philipp Leitner. I was one of the two awards co-chairs this year, and I have the honor of leading the session where we present the winner of this year's Most Influential Paper Award. So okay, here we go. In order to do that properly, we kind of need to look back a little bit, or a lot, depending on how old you are. So we need to look back 10 years to beautiful Karlsruhe in Germany, where the second ICPE has been organized, interestingly by people who are also pretty involved with ICPE 2021, namely Vittorio and Samuel Kunev, who I'm sure many of you have also seen in the organization of this year's ICPE in one function or another. And so this was the second ICPE ever, and this gives us, and since this was now 10 years ago, this gives us the opportunity for the second time in ICPE's history to actually give out a 10-year Most Influential Paper Award. And a 10-year Most Influential Paper Award is really, what we're trying to do with that award is we're trying to look back to the ICPE instance 10 years ago, so the one in Karlsruhe for this one now, look back at all the different research contributions, all the excellent papers that have been presented there, and kind of with the benefit of hindsight, identify which of these papers is actually has been the most important, which has been the paper that most people have built upon, that most people have cited, that most people have used, that has been deployed in practice the most. And that's essentially what we're trying to do today. And obviously, as you know, as the awards chairs, the duty has fallen on me and Marius to select this pretty important paper award this year. And what we have been doing is we have been doing the thing that academics always do when they get an important duty that they don't really feel ready for. So we formed a committee consisting of these, me and Marius as kind of the awards chairs this year, and then Alberto, Stefan, Andre, Radu, Klaus, Jose, Torina, and Petre. And the way how we selected the awards committee is all of these 8 names that you see here, except for me and Marius, all of these people have been already part of the program committee back in 2011, and they're still part of the program committee of ICPE now in 2021. So that shows you quite a bit of commitment to the community in a way. And really the job of us and of this community, of this committee, was to find from these papers the one that has had the highest impact in the last 10 years. And essentially what we have been doing is we have been, it was essentially 2 phases. In the first phase, we asked for candidates for papers that somebody in the committee felt should at least be in the discussion for this Most Influential Paper Award. And then in the second phase, so we got about 5 candidates in that way. And in the second phase, we then went and did a little bit of detective work. We went through all the different papers. We read papers that cited our candidates. We tried to figure out to what extent the ideas that have actually made their way into practice, whether there were any patents, whether there was industrial adoption of these approaches. So quite a bit of work for us and also for the committee, for which I'm very, very thankful. Many of them are also here today. But the good news is after we have done all of this work, our decision was actually very, very easy. So the good news is after we have done all of this work, there was an unequivocal decision of the committee to award this year's Most Influential Paper to Katja Drubiani and Anne Kociolek. I think at least Katja is here today.
So Anna, I saw her.
I'm there. Hello.
Hey. So congratulations to Katja and Anne again.
Thank you.
So
Thank you.
The award was already announced yesterday, but let's just give her another round of applause for this big accomplishment for the ICPE community.
Thank you.
Applause from me, and I see also Alberto and a couple of other people clapping. And really the reason why we selected this paper is because this idea of anti-patterns is such an important idea in the community by now, which it has not always been. So the idea that, you know, performance is always seen as something a little bit chaotic, and, you know, you can never really figure out what happens in the system if you do changes, and, you know, you really need to try everything out. But what this paper that we are awarding today has shown us is that while it is true that performance is hard to measure, there are certain things that are just generally not a good idea. And the paper that we are awarding has shown this for architectural models in Palladio. We have seen similar ideas for all kinds of other systems now, and we have really seen that this idea of performance anti-patterns is something very, very useful and also very persistent through all kinds of performance models. So normally this would be the time where we would be asking Katja and Anne up on stage and, you know, shower her with our congratulations. Unfortunately, we can't really do this time. So what we're going to do instead is I have a video prepared by Katja with her award talk, and I'm going to play the video. And then afterwards, I think Katja will be around to answer questions. Thumbs up. So I'm going to go and launch the video now.
Hi, I'm Katja Trubiani, and I'll be presenting a paper co-authored with my colleague and friend, Anne Kozelek. Since it has been awarded as the 10-year most influential paper, we will focus the presentation on what we think it was, its impact. We try to give an overview of the work starting from the foundations, and this means to go back roughly 10 years around 2001. We briefly present the content of the paper exploring its impact. The absolute number of citations is not the only index to be considered in our opinion. We found some references that are very relevant, and we will tell you why. Last but not least, we are researchers, so we also tried to imagine the future. What will happen in the next 10 years? Let's try to guess 2031. Motivating performance is too easy for this venue, so we are reporting a sentence from Mark Harman, outsider of this community, saying that performance is the new correctness. But how to measure performance? From ICPE, we know that there exist models, and starting from requirements, we are able to derive a performance model by which we can quantify the system performance characteristics. But if the requirements are not fulfilled, then the key question is what to change at the model level so that the requirements are all satisfied. So let me briefly report the main operational steps at the software performance process. First, modeling, an annotated with performance-related characteristic software architectural model is built. Second, analysis. With model-to-model transformation, we get a performance model. We solve it and we obtain a set of performance indices of interest. Focus of our research is refactoring. That means interpretation of the performance numerical results and feedback generation. So defining a set of design alternatives aimed at improving the system performance. And to this scope, we are actually using performance anti-patterns. Let's move to foundations. 10 years back, anti-patterns were defined as the negative features of a software system, and the definition includes both common mistakes, bad practices in the software development, as well as their solution. So they are conceptually similar to design patterns, recurring solution to common design problems. It's basically what to avoid and how to solve the problems, the performance problems. So for software performance anti-patterns, we need to give credit to the work of Smith and Williams that collected a list of 14 different anti-patterns across several years. Context of the ICPE 11 paper was to customize the software performance process using Palladio as architectural language, defining then anti-patterns based rules and actions in terms of PCM model elements, thus to automatically detect and solve performance anti-patterns. But why Palladio? Palladio because it includes a fair amount of information we needed for our goal, such as hardware resources, network resources, software ones, but also the possibility to specify the workload, the operational profile, the dynamic behavior of services, and so on. When matching the specification of anti-patterns with the formal language, PCM in this case, there are anti-patterns that are detectable but not solvable. Some others that are neither detectable nor solvable, and others that are instead detectable and solvable. So in this case, we were able to implement the detection of 6 different anti-patterns and the solution for only 3 of them. Let's consider one example, the concurrent processing system. Problem: processing cannot make use of available processor. It translates to a certain set of rules. First of all, queue-length rule, a PCM resource container that has a high average queue length. Second rule, PCM resource container has also a high average utilization. But at the same time, there exists another PCM resource container that has a low average utilization. Note that all the rules are based on threshold, so it's up to us to decide what is high, what is low, and so on. Let's take a look to the solution and the actions that can be put in place in order to solve, for example, the concurrent processing system. So from Sweet and Williams, we know that solving the concurrent processing system means to restructure the software or change scheduling algorithms in order to enable concurrent execution. So we were defining a set of different actions. The balance load action means that if 2 resource containers offer the same interface signatures, then we can change the scheduling algorithms in order to balance the incoming request. Mirror action, it means to mirror a certain set of components again to balance the workload. Most critical action, we need to identify the component that has the highest resource demand in order to redeploy it in another resource container. Redeploy action, redeploy a set of different components based on their resource demand and their interaction. So in the paper we had a case study. Running the performance analysis, we started from a predicted system response time of 18 seconds, whereas the required value was 10 seconds. So through the detection and solution of anti-patterns, we were detecting a list of 7 different anti-patterns initially. And then for the solution, we were applying some of the rules that have been defined. In this case, for example, the graphical reporting component was selected because it had fewer interactions compared to other components, but also a significant CPU demand. For experimental results, the key benefit that we had in experimental results is that we were able to automate the analysis, so the response time was evaluated through different rounds of iteration, in which in each round we are basically detecting and solving anti-patterns, and the required value was achieved at the 4th iteration, for example. But let's move to discuss what is the impact of our work. First of all, research impact. We think it was very relevant that it was cited by papers with a high impact as well. For instance, in a survey on software smells, our work was in line with the performance type of smells. Our detection method was based on rules and heuristics. We impact on the system quality, performance in particular. And interestingly, causes can be related to many factors. Everything may affect performance. In the table comparing the different smell detection methods, we result to be in line with the number of smells that other approaches are detecting, especially when looking, for example, at a work that was using UML diagrams in which the number of smells is pretty comparable. Let's see other works that were citing our paper. So again, on research impact, our friends started to work on a similar problem, And they published the paper at the ICPE 2 years later, sharing with us the idea of building a hierarchy of performance problems, but applying it to a well-known benchmark. Another type of impact was also stimulating industrial research. In fact, we found a reference of a paper co-authored by people working at Microsoft Research in Redmond in US. So they were developing a tool for performance anomaly detection with two main specificities. So they were using production data and visualization. We also were trying to address these points later. In fact, later on, for production data, we were developing an approach detecting software performance anti-pattern based on load test and profiling data. For visualization, we were collaborating with the Swinburne University in Australia and using techniques already available by visualization experts, so that the visuals, by looking at the visuals, we know the impact of software performance anti-patterns. Two examples are reported in these slides. We have the circuitous treasure-hunt anti-pattern that does not seem to have a big impact. In fact, the visual patterns of the performance metrics are similar across the columns. Instead, if we look at the blob resulted to have a high impact on throughput values, especially on the throughput of a specific service. You can notice that here the throughput is much higher when compared to these other columns in which the anti-pattern was not applied. So, another types of impact, our paper was also inspiring several research projects. We found references on deliverables of the following projects: Cloud Scale, Scalability Management for Cloud Computing, that is an European Commission framework program, whose budget was of 4 million. NIC 2020 project, DICE, developing data-intensive cloud application with iterative quality enhancement, again with a big budget. And also the German Federal Ministry of Research and Education, on which we collaborated, DAGSYS IT, expected guided automatic diagnosis of performance problems in enterprise application. An even more different type of research impact is triggering new and diverse lines of research. So we found a reference on a framework that was designed to discover and clean anti-patterns in arbitrary SQL query logs. It was tested on a real project, including more than 40 million queries, and 6 different types of anti-patterns were found. Let's move on. So also in our career, we both got an academic position. We were awarded by Microsoft Azure Research for a project on detecting and solving performance anti-patterns in cloud environments, and we were keeping working on the topic. So the journal extension of this paper was considering a guilt-based handling of performance anti-patterns. In particular, it means that anti-patterns are compared with the requirements, and the rank is given in order to indicate how much impact they have. So we found that high-ranked anti-patterns, they had a beneficial, they were more beneficial for system performance when compared to low-rank anti-patterns that instead were less beneficial. We were applying this strategy of guilt-based solution to several systems, and on average, we were able to discard around 30% of candidates without compromising the system performance improvement. More recently, we were collaborating with the University of York, and we are detecting and solving performance anti-pattern using continuous time Markov chains. And we introduced something that has been called as performance anti-pattern profiles, meaning that the operational profile, they affect both the detection and the solution of anti-patterns, as we can see in these graphs. When moving the probabilities of taking a certain branching point, the detection of anti-pattern is affected as well. Let's move to future work. What's next? 10 years from now. So we list some of the research directions that we are working on. So first of all, exploring specific domains, like for example, cyber-physical system. The idea is to extract domain-specific peculiarities and matching these peculiarities with the performance modeling. Yesterday, Ricardo was presenting a paper in which we were looking at performance anti-patterns for cyber-physical system. Another direction is to understand a bit better if it's possible to have multiple models and to make an analysis that is collaborative. For example, by using heterogeneous models, queuing networks and Markov decision process, is it possible to identify the interaction among these performance models and how this interaction would help to simplify or to make faster the analysis? Uncertainty reduction, it was in the keynote of Sven Appel. Acquire further knowledge on the system uncertainties and then compare the different alternatives including uncertainty. So let's think about the design alternatives that are including uncertainty. Is there a way to rank these alternatives taking into account also their uncertainty? Even more, so there is a need for a continuous update of performance model. Trace back system measures. The information that is also induced by used technology might be helpful in order to improve the power of using performance model. And also reverse engineering some message-oriented system because the activity of building models may be expensive. So we want to make it less expensive. We are also looking at keeping the performance knowledge base up to date. So what about if in natural language, in documents and meetings, we can then derive some performance model sketches? And then we are also interested to look at new types of systems to support the decisions on these alternatives, like data-intensive systems, message-oriented ones, or parallel application, or bioimaging pipelines with machine learning components. These are all directions that we would like to take in the future. And to conclude, we have a takeaway message that we think is relevant for all of us. So our takeaway message is work on what you like. Impact will be decided as matter of time and it's out of your control. And of course, we want to thank a lot of people that were collaborating with us. Thank you very much.
Thank you, Katja, from 10 years ago, and Katja from 1 day ago, or whenever this video has been recorded. So we still have some time to ask questions. And I see Alberto already has his hand raised. So Alberto, do you want to ask a question?
Yeah, I put the question on the chat. First, congratulations to Anne and to Katja. So it has been a pleasure working with you since, I think we started 2010, right? ICPE 2010. So it's been emotional.
In Princeton, 2008, so even before.
No, yeah, Katja was 2008, but I met in 2010, right? But we started working with Anne right after 2010, and then with Katja, we started 2018, 16, 17, right? A DAX tool, right? Anyway, it has been emotional seeing how you have progressed over the last 10 years, so congratulations. I feel proud of you. And the issue for me has always been, how do you transition from research to industry? This is the tough one, right? The gap between the research, the technology transfer, right? So how do you expect your work to be deployed in industry?
Thank you very much, Alberto. So this is a question that as researchers, we always have to deal with. So having our approach applied on research is always valuable to us because we are learning from them. So for example, the business reporting system, the case study that we were using was also later evolved in another case study from ABB. So it was already an attempt to look at a bigger system and a bigger complexity. So in general, we found with a few experiences, so I also tried to collaborate with the local industry, also in Italy. And it's always a kind of exchange because the industries in general, they do not like formal stuff. and the other way around. Then researchers are more addicted to formalize, to model, and so on. But this is a synergy that as researchers we should exploit. So as a future work for sure would be very relevant and valuable to keep collaborating with companies and to apply this research in practice. So it's our goal to learn from industries so that if we were not noticing something, then we can report about that and building, for example, even new different types of anti-patterns, for example. So it's always good to talk with people that are somehow, they have a different knowledge from you so that you can learn from them and the other way around. So it's very relevant for sure. The collaboration with industries, it's for sure very, very relevant for all of us.
If I may add to what Katja just said. So Katja mentioned that we also applied similar performance modeling things to a case study with ABB, where they actually had an architectural question that was important for the future roadmap of the system and so on. And they were willing to spend an effort and have a master thesis 6 months to model the system. But we also found that this is actually, well, I mean, as many of you here have too, there's quite a lot of effort to apply these, as Katja said, formal techniques that we researchers like in practice. So I think, and so maybe some advertisement, that this idea of bringing this or automating more or making the modeling easier is essential to make this more applicable for industry use. Not only for questions that are really important for the industry, because there, I think already today it makes sense to make the effort to model performance, but also to make it more applicable to maybe less important questions.
So maybe one of the main benefits of the ICPE paper was that we were able to automate. And this means that in our case study, for example, even if it was small, we were able to then analyze something like 400 different candidates, 400 different models. So having this automation was very relevant because it gave us the opportunity to look at further problems. So automation and is also a key point in industry, I think.
So there are 2 more questions in chat, and by Alexandro and by Andre, and I think they are related. And since we're kind of low on time, I will combine them into one question. And Alexandro is asking whether there are any performance patterns that have become sort of permanent laws, that have that are not transient things anymore, that have just become kind of something that always applies. And then Andre has kind of, as a follow-up question, asked, are there any specific anti-patterns that you see happen all the time that are particularly kind of persistent and prominent?
So it's not in the presentation, but anti-patterns were classified into main types. So there are the snapshot one, in which you basically are doing a photo of your system, and you look at the system in time. And some others instead that are looking at then the evolution of the system and how it will change along the time. So these types, I think that are very relevant, and they are different each other.
Bojan?
Hi, so I would like to also ask, hey, how are you? To ask a quick question, but before that, I would like to mention that I was lucky to actually know these 2 great researchers, both Anne and Katja. For the first time, I met Anne in a summer school 2010, before when I started my PhD, and her work actually was very inspiring and somehow gave the kind of work that I did during my PhD. And then during my postdoc at Concurrent College, I was lucky to meet Katja, and since then we have been collaborating a lot. So my question is that basically, has there any effort in terms of making this systematically, anti-pattern systematically reusable? Like, you know, that there are efforts in terms of making patterns, software patterns, to some repositories to make it reusable across different domains, in terms of but you know that there are method engineering to make it happen through instantiation, through some also repository maintainable repository. Are there any effort in terms of making this usable across different domains in a systematic way, which also relevant to what Alberto mentioned, making it to industry?
Thank you very much. It's a very good question. So from when we started, so from the exact beginning that we were reading the work of Smith and Williams, we were thinking that translating the work then in rules and action, it's our own interpretation. So since the beginning, we said we should build a kind of repository in which we encode our own specification, but then we ask the others to contribute, so that something that, for example, in our interpretation is a blob and is the collection of 3 or 4 different rules might be interpreted from someone else in a different way. And then the benefit would be to reuse the knowledge of all the people that can express their own problems, they can define their own solution. So it should be done. It's something that really it's worthwhile to build. So we have to do that. Yes, I fully agree that reusing this specification and also in collaboration with people from industry, but also from research would be very valuable to do. Yeah.
So I think we have time for one more quick question. Murray, you have your hand raised.
Yes, I wanted to make a comment about this idea of long-lived patterns. In the 1980s, Connie Smith enunciated some principles, performance principles for software. And I think you can observe that most of the patterns, maybe almost all the patterns that have been found and declared and defined are related in some way to those principles. And the principles are very long-lived. I haven't seen any of those principles go out of date, although software has changed a great deal. So I suggest you go back to Connie's principles if you're looking for sort of permanent ideas about patterns and anti-patterns.
Yeah, thank you very much, Mare. I can add that in this last year, I was collaborating with Connie, and anytime we were speaking about software performance anti-pattern for other physical system, I was mentioning, look, but this seems to me like the more is less, the one that I was somehow investigating 10 years ago now, no? Yeah, so right. It's exactly the case. So they have many similarities, and I think that it's very interesting also for this, because you can put in place these general guidelines and build new ones with some slight changes. So it's incredibly nice as a domain, I think.
Yeah, the patterns are embodiments of the principles, I guess, a bit more concrete and specific to domains and so forth, but there's lots of permanent value in them.
Right, and also for anti-patterns. So you discover an anti-pattern, for example, when you have some variations like the workload, no? So the workload starts to be a certain value and then it's increasing. And the anti-pattern is showing up only after a certain amount of users that are using the system in a certain way. So this up to a certain point it's a pattern, but it becomes an anti-pattern when some of the parameters are changing. So yeah, so understanding the boundaries, it's very relevant, because then you go back to the designers and you tell them, look, that up to 100 users, almost fine. But after you will encounter some performance issues. And I think it's a relevant information for all of us.
So unfortunately, I need to cut this very interesting discussion short, because we're already 5 minutes over time and the PC chairs are starting to get mad at me. So thank you, everybody. Congratulations again to the winners of this year's Most Influential Paper Award. And I'm not sure what we do next. Do we go into break now, or?
No, we have since 5 minutes the session I'm chairing.
Okay, so
yeah, the break is up. There is a coffee break. I mean, a break after the next session. So the session will start right now. Yeah.
Okay. Thank you.
Yeah. And without
Thank you very much.
Thank you.
Thanks again to the committee. Bye.
So without further ado, I would ask the first presenter of this session, which is Axel Busch and Martin Kammerer, to share their...
Yeah, hello.
Hi, Axel.
I think, yes, it should work, hopefully. I think it's not working. Not good. So, Steffen, can I send you the slides via Slack?
Are you co-host? Because I think you need to be made host before you can share, right?
Yeah, but maybe the macOS settings are the problem here.
I can try to give you more rights. That's not a problem. Is it? No, I can't. No, I'm not allowed to give you more rights.
I don't think it's a problem. Everybody should have right to share the screen, I think.
That's what I assumed, at least.
Yeah, everybody had the right.
So maybe we just turn around the order and we start with the next talk, and then in the meantime you send me the slides and I try to share. So let's go to the talk by Johannes Krohmann. Are you here, Johannes?
Yes, can you hear me?
Yes.
Okay, then let me try sharing.
That seems to work.
Okay. So does this work?
Yes.
All right, great. Then I'll just start, right?
Yes.
Yeah, cool. So yeah, hello. I'm quickly going to introduce our approach for Suan-Min. Suan-Min was developed by me and my colleagues at the University of Würzburg together with Huawei technologies from Tel Aviv in Israel. And with Suan-Min, our idea is that basically we have a microservice application run in the cloud, and we have monitoring stack, tracing infrastructure like Pinpoint, Kika, or Zipkin. And this is working great. However, the problem is that we only have reactive monitoring. So obviously the monitoring can only record what's actually happened. So if I have some action, for example, scaling because my performance is somewhat bad, then yeah, the problem is that also the reaction to this performance problems is obviously late because it can only come in once my performance deteriorates. So yeah, what we want to achieve is to move this reaction further into the past in order to basically take its effect before actually the user experience deteriorates. And this is what we want to achieve. Yes, our idea for this is basically this 5-step approach. So we envision this small example here. We have an application, and at the front end we have the user calling some services that are user facing. And first we need to have the load forecasting. So we need to know what are the requests for the next interval. And based off this, we do request propagation, which is the second step. And we see that we can now infer that the requests propagate through the system and which or how many requests will arrive at each system. And now in the performance inference, we actually focus on determining, okay, is this amount of requests, is this fine, or does it lead to a performance problem? And then we can also relate the performance problem back to the other services. So these errors here, on the one hand, they show the propagation of the request, but on the other hand, also the dependence of performance problems. And also now we saw that here service H was actually the problem. So we also have the root cause detection here that we can apply in order to find out that actually the problem that the user is seeing here at service A is basically down to a problem that we have at service H, and that's why we need to fix that one. And yes, in our evaluation, we looked, for example, at the train ticket shop which looks somewhat like this. And during normal load, we have all services green, so all respond well. And now if you try to stress the train ticket, so it's a the train service, which is a backend service, then you actually see that all those other services that are calling them get influenced as well, but they are not the root cause. So if I solve the problem with the train ticket, those problems will also get away. And this is what we also saw in the evaluation, and that we could also predict using our approach. Yes, so finally, to summarize, our problem was that we have only reactive reactions using APM. So we want to enhance that with prediction and proactive tools. And yeah, this gives us the power to avoid the performance problems before they happen. And I just showed you a quick glance at our 4 steps on which we try to achieve that. So thanks very much. And I'm now very happy to answer your questions.
Okay, thank you for your summary. Questions exist already in Slack, and as we don't have one here, so Murray, you asked a question in Slack. Can you repeat it online?
Okay, so I have a very specific question about the test that you did, the example in which you inserted a performance problem in terms of a delay into one of the rightmost services that everything depended on. And then you found that you were able to predict how this affected the other services. And in doing that test, how did your system learn that you were inserting a periodic delay in that service? Because it's not a system parameter.
Yes, so exactly. So it's not a system parameter. The time is not included in the performance model itself. So the performance model themselves, they are time agnostic, so to say. So they just rate the current state. And the delay that we inserted was due to an increase in requests. So the request pattern had to be learned by the forecasting engine there. Okay. So once then the delay increases, then we see that this would then propagate during the. Okay. Yes.
Thanks.
And I think in Slack you also had an additional question, which I'm just going to answer as well, since we're here.
Okay. Oh yeah.
Yeah, this was about whether if we have an additional performance metric, whether we would need monitoring for that, right?
Yeah.
And the short answer would be yes. So all of our models, they need monitoring data to train for that. But that's actually a nice question, which is why I chose to answer this well now. Because of course you could do something like, if you have more than one performance metric, you could go ahead and try to infer one metric using the others without actually measuring those. So this is very interesting, something that we didn't think of yet. Maybe we want to explore something like this in the future, but currently you're correct. We require monitoring basically for all the models to be built and for all the different metrics, yes.
Yeah. Thanks.
Okay, there are no further questions besides mine, so maybe I just ask mine a little bit shorter because we're running out of time. So I was concerned also with the self-adaptation feature of microservices. For example, if you run it on Kubernetes, it should self-heal. And how would that impact your approach?
Yes, so this is also a really good question. The problem here is basically similar to the regular APM. So basically we are reactive, right? So we can only react to something that we already observe. So this is why we are also too late if we go to that level. Then you could go ahead and say, okay, we can also use a forecasting engine at the individual service level. That's correct. But we think that you need somewhat the whole application scope to actually infer the performance in the future, right? So if you have just the one view of one service, it's really hard to determine how many requests will arrive here because you do not have an overview of the application flow itself. So that's why we think if you want to really do a prediction, it's important to have the whole application view. Why you cannot focus on the single microservice. Does that answer your question?
Yeah, at least I understood now what your rationale behind it was. So thank you. We have to move on. So I try now to share Axel's talk.
I would like to try again.
Okay, please.
I think I fixed it.
Please go ahead. Oh, now it looks better.
Is it working?
Yeah. So that's talk one. Now talk number one for those who came late. Technical issues. Axel, please go ahead.
Yeah, all right, thank you. So yeah, what is the paper all about? My colleagues and I, we have quite investigated a lot regarding networking performance and influence of software-defined networks on microservice architectures on the example of the Red Hat OpenShift container platform. And the reason is IBM and Red Hat started a collaboration a couple of months ago to bring the Red Hat OpenShift container platform on the IBM C mainframe system. And when we have a look at those kind of hybrid cloud systems, we typically see that there are a couple of cloud native applications running on a kind of Kubernetes service with an OpenFlow switch and some hardware resources that are underlying. What we see when we have a look at those applications, we see that they have a quite high demand of networking capacity, and they are demanding low latency. So this means we require quite efficient hardware and software networking stack to have best performance for the customers. And this is why we had further investigated, dig deeper into the OpenShift SDN from the OpenShift container platform here. Typically, we use micro benchmarks for the analysis of those kinds of systems. We use here UPerf, providing us two types of workloads that are interesting, namely the request response workload for the latency and the streaming for the throughput. And of course, you have a couple of parameters you can adjust, like the number of connections or the different request sizes. You can fine-tune your workload simulation. And typically, we have, let's say, two kinds of application communicating here with each other. One is taking the role of the client, and one is taking the role of the server, and then they are communicating to each other. And in the end, it results in a latency and throughput. It's as similar as you know, probably. Okay, so let's have a quick look at this system architecture. Basically, we can say we have kind of three parts in those kind of system. On the left, we see the cluster with a couple of master nodes, 3 of them, and a set of worker nodes. In the picture, we have only 2 of them, but of course, we can have an arbitrary number of workers. It's up to your resources. And all those nodes communicate in our setup via a CVM vSwitch. It's the switch, virtual switch from the hypervisor CVM here. You can compare it with KVM MacVTAP, or yeah, it's pretty similar. And all the traffic goes then over the physical hardware NIC to the so-called Bastion node, where a HA proxy is running on. It's a software solution for making high availability, and it's also used as a kind of perimeter network to disconnect or separate your cluster from the outside world. And you can see that's a kind of complex system, and what we did experiments. One time the workload, what we have seen inside the cluster with the red bar, and one time without, just let's say bare metal, not bare metal, but virtualized in containers via Podman. And what we can see is that we have up to 5 times higher latency here. And this brings us to the question, why is this latency increasing? And a part of the answer is because of the OpenFlow switch, OpenFlow rules and Open vSwitch, how it is built and how the architecture is designed. We can see that when we have a closer look to the switch and the pipeline levels with all those tables that represent the level of this pipeline and all of those rules applying in that pipeline. And imagine each and every rule has to be applied to each and every packet. And that can sum up quickly and increase the latency of those kinds of systems. This is what we have seen in the experiments in the paper. I cannot explain that here, but look in the paper and you see that we analyzed some kinds of shortcuts. And with the shortest path we could found here, with the blue bar, you can see that we get quite close to the, let's say, bare metal Podman latency. This is also affecting the throughput, not only the latency, but those huge pipeline level. We can see that it highly influences here the latency we can get. Okay, so that was my teaser presentation. Thank you so far. And if you have questions, please feel free.
Thank you, Axel. I saw a question from Murray in Slack.
Mm-hmm. Hi. Sorry, yeah. So my question is, it relates to, I'm a modeling person, so when I see measurements, I think of how could I abstract these measurements a little bit to generalize them. I noticed that you mentioned some other work which did a bit of modeling. I wondered if there's any connection that you could make to generalize your results, or whether that's not maybe relevant.
Yeah, good question. No, thank you. Yeah, of course. I think we could use such an approach for modeling those kinds of workloads and simulating those workloads without having the system involved. And yeah, maybe this is because I'm coming from Anne's Lehrstuhl, and I am always in those kinds of experiments, and that would be interesting, of course, and could be kind of future work. Is it answering the question?
Yeah, that's great. I just wondered what you saw in that, whether there was some barrier or maybe.
Well, of course, yeah. This is a research topic, of course. I cannot answer in detail, but I think modeling could be possible. Right? Yes, absolutely.
Okay. I see no further questions, neither in Slack nor in the chat. Mine was answered in Slack, so if you're interested in this, you can have a look in Slack too. And given that the time is already advanced, I think we should move on to the last talk in this session. Thank you, Axel. So the last one is by Laura Carnevali. Are you here?
No, I'm okay. The second author. I'm going to, yeah.
Ricardo is giving the talk. Great.
Yeah, thank you.
Stage is yours.
I'm going to share the screen. Can you see it?
Yep, works.
All right. So, this is a paper that I worked on with Laura Carnevali and Enrico Vicario. Yes. And in this paper, we propose a compositional approach to evaluate the cumulative distribution function of the completion time of complex workflows that have concurrent transition that are also generally distributed over bounded supports. The compositional approach decomposes the workflow and minus 3 mu e. Sorry, I'm hearing something okay, thank you. The compositional approach decomposes the workflow, and once the workflow is decomposed into blocks, these blocks can be analyzed efficiently in isolation. And finally, the intermediate results are recombined numerically. And we tested this on a composite web service. Our workflows are modeled as stochastic time patternettes, and we consider well-nested composition of concurrent activities, which consists in these 5 patterns that you can see in this figure. And workflows, workflow transitions are distributed as bilateral truncated exponential distribution, whose parameters are evaluated by fitting the mean value and the standard deviation of histograms that are obtained starting from samples of this dataset called WS-DREAM. And before the collection of the samples into the histograms, we applied a regularization rule, which is named Taki's rule, that dropped the outliers. The approach is based on 4 main operations. One of these is the decomposition, which is applied whenever a workflow is considered too complex. And this is driven by its topology. And in particular, we identify 2 strategies, which are called the split and join strategy, that decompose the workflows respectively into 3 and 2 blocks. Another main operation is the complexity evaluation, which is done applying non-deterministic analysis on the workflow. And this kind of analysis enumerates a state class graph, where a state class is a tuple consisting of a marking and a time join domain. And this graph allows to identify regenerative states and to describe the concurrent behavior of the workflows. And this enables some heuristic through which it is possible to evaluate the complexity of these workflows. Then when a block is identified, it must be analyzed. And the blocks are in the class of Markov regenerative processes. And in this case, it is possible to compute the transient probability of a certain state by solving a system of integral equation of Volterra, which is done numerically, and this will introduce an amount of error in the final results, assuming that we are able to compute the local kernel L and the global kernel G. And these 2 kernels are computed using the method of stochastic state class, where a stochastic state class is like a state class that adds a probability measure. And the point in this case is that this stochastic state class must be enumerated to form the stochastic state class graph. And in the enumeration, the presence of regenerations make this enumeration more efficient, because it is possible to limit the enumeration before a regeneration and then repeat it for all the regeneration. And this is also the reason why we decompose the workflow into isolated blocks, because in the isolated blocks, the number of regeneration may increase. In the end, we have the last main operation, which is the numerical recombination of the intermediate results. We tested the approach on a model, which is an extension of a travel agency composite web service, and we did it for different settings. And for all the settings, we compare a 50,000 run simulation with our method using the Jensen-Shannon divergence as accuracy measure. And in terms of accuracy, as you can see from the table, which shows the different time t cases used for doing this experimentation, we always have very low values of Jensen-Shannon. And in particular, these values are proportional to the time tick. And but this was expected because the method of Volterra introduced an amount of error in when discretization is applied, since it is solved numerically. And regarding performance, we also got low values. And in this case, the performance is inversely proportional to the time tick. And but if you look at the worst case time analysis, the simulation, takes about 15 times than the analysis. And at the moment, we are working on an extension. We are trying to apply the method over workflows that exhibit non-well-nested structure like replicated events and repetition. And this is all, and I would like to thank you for the attention.
Okay, thank you for your brief summary. And Murray has some very interesting questions in the chat.
Do I have to stop the sharing?
You can leave it. Maybe
not for me.
Oh, okay.
So Ricardo, in workflow, sometimes if you have a large data set going through a set of processing, for instance, there's correlation between the the time spent at different steps. Am I right in thinking that this correlation is not really covered in the analysis so far? Wasn't quite sure whether you have that.
Well, in this case, okay, thank you for the question. Well, in this case, in the model, in the workflow, there is no correlation because we consider a well-nested composition of patterns. And so when we decompose the workflows in blocks, we are guaranteed that blocks are in certain point independent between each other. And so there is no correlation.
Right, okay.
I don't know if this answers.
Well, I mean, if there was a correlation between the time spent on different steps in the workflow, it could be a problem.
Yeah, if I can also say something together with Ricardo in the answer. I guess that the question was about having correlation in the durations of different activities.
Yes, exactly.
We don't take this into account. We assume that durations are IID variables, so independent and identically distributed at each call. I guess that under the topology that we are working on, we might prove that if dependencies are positively correlated in the data, then what we get is an over-approximation of the distribution of the completion time. This is a guess because it's very close to things we are working on now. We don't take into account dependencies in durations.
Okay.
Thank you. Further questions?
I got a question.
Alberto.
Okay, so Ricardo, Laura, congratulations first. And nice work. And the question I have is, okay, suppose you have error, right? What would be the consequence if you're going to apply this in practice? If you're going to take this and help somebody design something, is this error something that's going to make your approach less useful? Or, as you mentioned, this worst case is still in the bounds of applicability?
Would you mind to repeat the questions? Because I didn't catch.
Yeah, because one of the reason you do this is to solve to solve real problems. A model is always wrong. Some are useful, right? So your model is useful. The question is if there are correlation, if there are errors, does it become, to what extent it becomes less useful, or it is going to be something that could be overcome by other engineering aspects. For example, the estimation of the average of the distributions, all these things we do introduce error, right? So if you can solve it, assuming IID, maybe it's good enough, right? Is it good enough, the IID distribution? Or for practical applications, you need to go in more detail and consider the comments that Murray said, right? So what's your feeling about this?
If I can also help in the answer, because Ricardo is at the end of his first year in PhD, so it's the first time for him to present a paper.
Yeah.
Yes, for instance, this can serve to support automated service selection. For instance, this is a case. But also, if I go back to the paper that was presented, not one, but the paper on Xuanming tool that was in this session today, this can be a tool to support that kind of analysis. The point is that this can come into play when you are interested not only in mean value and deviation, but rather when you need to have an evaluation of the complexive distribution function. And this can come into play in a relevant way when you have, for instance, soft deadlines or service level agreements like this. So, and yes, we are driven by the idea of applying this. Strangely enough, we are applying this technology in two very different areas. One is in quantitative supply chain management, where times are days or weeks, and the other is the area of composite web services, but also microservice applications, and experimentation is now going on using functions as a service, as a particular technology to target this.
Okay, thank you for the questions and answers. This concludes this session, leaving us a bit about 10 minutes for a break. Because ICPE continues 5:15 Central European time with the session on benchmarking. So thank you all for keeping the time.
So meanwhile, we are waiting in preparation of session 6. I would like to ask if the presenters are here, and to communicate that Riccardo Pinciroli will substitute me as session chair.
Yeah, I'm here.
Okay.
I'm also here.
Okay, so we collected together the information and he will present you. Andrei is first, right?
As far as I know, yes.
Yes.
Should I start sharing my screen?
Yeah, maybe we can take the advantage to check if there are technical issues. Okay, yes, we can see the screen.
Good, thank you.
So I remember that each of you will have 10 minutes. The suggestion is 3 minutes for the teaser and 7 for the questions, but then you can arrange in these 10 minutes how you prefer.
Okay, so it's 5:15, so I think we can start. Well, first of all, welcome to section 6 on benchmarking. The first presenter is Andrei Bauer. He finished his PhD last December and is leading now the research group Software Engineering for Applied Data Analytics at the University of Würzburg. We will talk about Libra benchmark for time series forecasting methods. Please, Andre, go ahead.
Thank you for the introduction. I will briefly introduce Libra. So, forecasting is an important task for many decision-making fields. And one may ask if there's one forecasting method that performs best for all fields. But the no free lunch theorem denies this possibility because there is no globally best method. That means each method has its benefits and drawbacks according to its use case. So the common practice is either to do trial and error or to consult an expert. However, both approaches are prone to error and can take time. So we try to face the question how to select the best method. So we started with looking at the literature. So we did a survey with more than 100 papers. We have some criteria for selecting them, and we were interested in how many measures, how many methods, and how many time series these papers used. As you can see here from our outcome, most papers considered at maximum 4 measures, 8 methods, and 9 time series. And moreover, none of this paper considers time to results information. That means the studied papers provide no basis to guide the choice of how to find the best forecasting method. So we come up with the idea to build an own forecasting benchmark to have a standardization. And our benchmark is called DRIPA, and it automatically ranks and evaluates forecasting methods, has a diverse scenarios in numbers 400 time series. We have several forecasting accuracy measures and also time to result measure. The time series are split into 4 application domains: economics, finance, human access, and nature and demographics. Here are the characteristics of the time series, so the distribution of frequency and length in each application domain. And when the user wants to use Libra, he has to select the application domain and whether if you want to do a 1-step ahead forecast, a multi-step ahead forecast, or a rolling origin forecast. And by building Libra, we also perform some measurements. And in the end, we had 10 reference methods that we include into Libra. So if one is using Libra, he can compare himself against these methods. And here is the summary of the 5 best methods. And the takeaway here is that the machine learning methods have a higher forecast error than classical methods. But the machine learning methods are faster than the classical methods. SREMA is the most accurate method, but is almost 1 million times lower than SNaive. And XGBoost was the most accurate machine learning method and is only 7 times lower than SNaive. So in a nutshell, forecasting is an important task for many decision-making fields, but the no-free lunch theorem makes it hard to find the best method. So our idea was to establish a benchmark for time series forecasting methods. And it has 4 application domains, 100 time series in each use case. We have several measures, and we had 10 reference methods, and everything is open source. So source code is located at GitHub, and we also create a reproducible code ocean capsule so everyone can rerun our experiments. So thank you for your attention. Here are the references, and I'm really looking for questions.
Thank you, Andre. Is there any question from the audience?
Can you please comment a bit on time to result? So can you tell us a bit more on which metrics did you collect and what was the forecast?
Of course, yeah, it's the whole runtime of a forecast. So the forecasting method gets the time series as input, builds the model, makes the forecast and delivers the forecast, and the whole time from start to end, we framed it as time to result. So when I started doing my PhD, I was working in auto scaling, and I had the problem that the quite accurate methods took a lot of time to make a prediction. So sometimes it ranged from minutes to hours, and if I want to apply auto scaling decisions in minutes, for example, in minutes, every minute I can't wait a lot of time. So therefore, I'm trying to find a good balance between time to result and forecast accuracy.
Thank you.
You're welcome.
Philip has also a question. Please.
Yeah. So one question I had when I watched your video earlier was, so you have this, I think I have some troubles understanding really the goal, because on one hand, you have this claim that clearly there is no approach that's best for all kinds of time series, which I totally believe. But then on the other hand, you have this benchmark, which sort of seems to have as a main goal to compare across different time series. So isn't it kind of, isn't that you really need a bunch of different time series for different domains so that you can say, you know, if I want to predict financial data, this is kind of the benchmark that I need. If I want to predict something else, then I need this other kind of benchmark. It feels to me you kind of start off with this idea that, you know, specific techniques are good for specific things, and then you still end up with this kind of one thing to compare them all, kind of overarching approach. So can you comment a little bit on what the goal, like what are you really trying to do? Are you trying to have something specific, or do you want to kind of compare across different domains?
So it's more of a letter to compare across different. So I try to find time series and to cluster them in different domains. So I can't say like one's the best for all. So I don't want like one fits all solution. I'm aware, because of this no free lunch theory, there is no method that performs best. So I try to find a small like partitions where one could be better than the others. So for example, SREMA was quite good. And yeah, it's as the idea arose after the survey of academic work, because so if you want to find the best method, for example, for a certain field, you are looking for papers from this field, and then maybe I have papers that compare themselves with a standard forecast on 2 time series and claim they're the best method for this field. So the idea was also to encourage people to do further experiments to have a better, like a base for comparing time series forecasting. So I try to give them somehow a guide or a hint to how to compare them. I hope it was the answer to the question.
Yeah, thank you.
You're welcome.
Maybe we can read a question from the chat. Hang Lee is asking, do you think that deep learning methods may have better results?
It could be, but deep learning in general need a lot of data. And I have, for example, time series with 70 data points. That is, from my experience, too less for deep learning. And in this, or how a benchmark is built, you like submit the code of a benchmark, of a forecasting method, and when it's performed. So deep learning have to either to learn across a lot of time series at once, or need to retrain. And so we try to generalize the data at first and then have to retrain, And in this current design, it's not possible to use deep learning because they would only get one time series at a time. So they will fail there. Of course, one can use deep learning. And for example, one forecasting method that win the M4 competition has deep learning, but it is so good because it uses all 100,000 time series at once for learning and not one time series at a time.
Okay, thank you. So there are some other questions on Slack, so please take a look also.
Yeah, I will. Thank you.
Let's go to the next presenter. He's Günther Hesse. He's a PhD student at the Planetary Institute in Potsdam, Germany, and he will talk about ICPE bench, the enterprise stream processing benchmark. Please, Günther. You can see your screen.
Yeah, thank you. Thank you for your introduction. Can you see my screen?
Yes, we can.
Great, thank you. Yeah, hello. My name is Günther Hesse, and today I want to present some work that my colleagues and I did about benchmarking stream processing systems in the enterprise context. So we developed a benchmark called ICPE bench, the enterprise stream processing benchmark. So we recognize the situation that the stream processing is an increasingly popular field with many or growing number of data stream processing systems being developed, such as Apache Spark, Apache Flink, Hazelcast Jet, and also commercial systems from like Google, Amazon, SAP, and so on. However, we ask ourselves, how can we find the best setup or the best system with regard to software, to configurations, hardware for a given usage scenario? So what are the advantages, disadvantages of certain systems in which setups, and how can we compare them quantitatively? So the natural solution for that is performance benchmarking. However, we felt that there was a lack of a satisfying benchmark for such scenarios, because there was no benchmark covering all core functionalities of data stream processing systems, and no benchmark that included the integration of business data that usually lies in a database management system. Moreover, we felt that there was no benchmark with a like comprehensive tool support that eases the application of the benchmark and that allows for objective result calculations. So that is why we developed ESP-Bench, as I said, which is an application benchmark from the high-tech manufacturing domain that provides the tool support and that covers all the core functionalities of data stream processing systems that we derive from other work. However, how does it look like? That's the big picture of the benchmark with different components. So at the top, you see the input data, which includes both streaming data, so sensor data, as well as business data, which is based on the TPCC benchmark. Below, you see the ESP-Bench toolkit, which includes the data generator, data sender, and a validator and result calculator, which is responsible for validating the query results produced by the system under test and for calculating the result KPIs. Moreover, there are certain configuration files that a user can use to configure certain aspects, such as the data input rate, so how many sensor messages should be sent per second to the system under test, or the duration of the benchmark. Moreover, there's a message broker employed, in particular Apache Kafka, which we use as the interface to the system under test. And the system under test comprises a data stream processing system and a database management system. The latter stores the business data, and as a default, we use PostgreSQL. So in order to ease the application of the benchmark, we automated the entire benchmark process using Ansible scripts. And over here, you see the activity diagram visualizing this automated process. At the beginning, we set up the benchmark parameters and compile the ESP-Bench toolkit. Then we create the needed Apache Kafka topics and reassign them so that they are distributed evenly. Then we generate the business data according to the configuration, copy them to the database node, import the data. We start collect D on all nodes to gather system KPIs like the memory utilization or the system load. Then we start the benchmark application, so the query implementations on the SUT.
30 seconds, Günther.
All right, and yeah, you can see the rest. We overall defined 5 different queries. You can find the details in the paper. The first one, for instance, checking the sensor status, so to check the state of the machine, and for other queries. To validate the benchmark and the tools, we implemented the queries using Apache Beam, which is kind of abstraction layer above data stream processing systems, which allows to execute implemented applications on any of the supported systems. So we benchmarked using this example implementation, Apache Flink, Hazelcast Jet, and Apache Spark streaming, and you can find the details also in the paper. Yeah, to conclude, we contributed ESP-Bench, which is available at GitHub with the toolkit and the concept, and an example query implementation using the Apache Beam SDK, which can instantly be used to benchmark different systems. And in the paper, we also published the results for benchmarking 3 state-of-the-art stream processing systems. Future work includes the extension to further domains and extended evaluations. Thank you.
Thank you, Günther. Is there any question from the audience?
Yes. I just wrote on the chat, so thank you for your presentation. I wanted to ask how you scale the workload for such an application and what metrics other than latency you use for evaluation.
Yeah, thank you. You can scale the workload with the configuration files, basically. So for the data center configuration file, you can determine how many messages per second you want to insert to Apache Kafka. So you can basically,
So basically, I was referring not that much to the technical aspect, more to the approach. I mean, you can scale the workload by increasing the rate of messages, but you can also increase the size of messages, or you could have multiple streams and increase the number of streams. So there are multiple ways to scale it up. That's what I meant.
I see. So we basically work with scaling the ingestion rate. That's basically what we do. And as metrics, we determine the latencies of the queries, so the time it took to produce the corresponding results, by using Apache Kafka timestamps. So in such a way, we can do that independently of any data stream processing system. You can configure Apache Kafka to store a timestamp whenever a message is appended to the Apache Kafka log. And we use that as the time when the message was made available to the system under test, and then use this for the result tuple as well, and then calculate the latency by that. Or depending on the query, we also use the timestamp in the database management system. That's what we use over there. And apart from that, we collect certain system characteristics across the entire cluster using collectd, which is also like fully automated.
Thank you very much. Very interesting.
Okay, thank you for the discussion and the questions. So I think we can go to the next presenter. He's Peter Samoa, a PhD student at the Chalmers University of Technology. And he's working with Professor Leitner on investigating AI and software performance engineering. Please, floor is yours.
Hello, everyone. So in this presentation, I'm going to, roughly speaking, talk about my work, which is about an exploratory study of the impact of parameterization on GMH measurement results on open source projects. So as we all know, measurement or benchmark configured with n parameters, each with m different values. So each required GMH to execute the benchmark m to the power n execution. So here is a benchmark or a GMH benchmark example. So we have a set of Java class, which define four benchmark methods, all annotated with @benchmark annotation. And also we have four user specified parameters that are defined using @params. Even with the modest parameterization leads to a combinatorial explosions of a benchmark that must be executed, hence dramatically increasing the execution times. So far, there's no research has investigated how this type of parameterization is used in practice and how important different parameters are to the benchmarking results. So that's why we designed this experiment study in order to support the developers in selecting appropriate benchmark parameter value. So in the fewest number of experiment runs, the developers can gain information about the impact of the benchmark parameters. So we start to collect the data on a purposive sampling. So in purposive sampling, subjects are selected explicitly based on the perceivedness, usefulness to the study goal rather than drawn randomly from the population. So we choose those kind of projects for our study that they are well known, important in practice, and well maintained. And we pick up the classes of the benchmark from those projects based on purposive sampling strategy. And then we start to do kind of study of the impact of the parameters either on the individual level or on the collective level. So in the individual level, we studied the correlations between the benchmark parameters and the performance values. So we had so many different results, and we choose those important results for our slides. So we have like either the parameters does not impact the benchmark at all, or they follow kind of well-known distribution like power law, or for example, step function. So for developers, awareness of, for example, this situation is crucial, as there is a little to be gained from executing the benchmark multiple times with the parameters value at the same range. And then we study the importance of the parameters on the collective level using the score, which is refers to the contributions of the parameters to the performance value. So the importance results here that we have a dominant parameters among all of other parameters on the class level. Eventually, as we have observed, most parameters does not impact on the observed benchmark results at all, or the correlation between the parameters value and the measurements follow a fairly predictable curve. Hence, we speculate that giving a sufficient training data, it's possible to infer the performance of untested parameters combinations with high accuracy without actually having to run the benchmark for these specific parameters combination. So that's why we, for example, for each class, we choose we have the input features, we pre-process those features, and we inject it into a machine learning model to achieve the predicted performance value. So we build a model on the class level because each class has its own set of parameters, and we obtain like high accuracy model based on R-square, which is a statistical measure that represents the proportions of the variance for the dependent variable, which is in our example, the performance value, explained by the independent variables, which is the parameters of each benchmark. So to sum up, we conduct the experiment study to investigate the parameterization of the GMH benchmark on a different level. We investigate the impact of the individual parameters on the performance results. So we have like 40% of the GMH parameters have no observable impact on the measurements results. Finally, we build kind of machine learning model that predict the measurements of the unseen parameters without really need to run the parameters and get the performance value. Thanks for attention.
Thank you. Is there any question?
Can I ask on the sampling part? So when you were mentioning about sampling of params and then in the relation with the features, can you tell a bit more to us about this sampling and how to decide when to stop sampling and so on? Okay, so we build our own tools for data sampling that iteratively execute the benchmark of the selected benchmark with a randomly generated parameters value. So we choose the range of the value for each parameters based on the configuration of the projects on the GitHub right now. And then we build kind of distribution, like Gaussian distribution for each set of parameters, right? And then we study the correlations accordingly. Are there correlations related also to the nature of the features that you are analyzing, or they are pretty similar depending on software features?
Depending on the projects. Yeah.
Okay, thank you very much.
You're welcome.
Any other question?
Peter,
Oh, please go ahead.
You say you predict performance for the unknown combinations of parameters quite accurately. So is that more interpolating or extrapolating, or does the accuracy differ in those two cases?
Yeah, the accuracy is differ across the models, which is built up on class level, right? So, but most of the models gain high accuracy, which means that as long as we have one dominant parameters that affect the measurements, so the curve of the correlation is predicted. So that's why we can apply machine learning, and that's why we gain these high accuracy models, right? So the majority, so like 99% of all of models gain up to 90% or above or 90% of R-square accuracy.
Okay, so what I was aiming at more was like, can you also predict outside the range of parameters that you've learned on, or is it mostly within the range of parameters?
No, you can learn. You can predict the untested parameters regardless the range. So we just build the range in order to have to have a sample for the data.
Okay, I think we have time for a last question. I see David has one.
Yeah. Cool. I was just, I enjoyed your paper. Thank you, and your talk. My initial reaction when looking at it was to see some similarities with the sort of space-time stuff and configuration space sampling that was discussed by Sven earlier in the week. And I realized they're different spaces. One is system configuration. This is parameters to a test. But it feels like there's some relationships there. And I was wondering if you could just speak to either what you think you can leverage from there or what is different that sort of separates things.
I know, as unfortunately I didn't follow the talk that you are talking about, but here we are talking about how the parameters of the benchmark affect the performance value. So usually the developers, for example, they want to do kind of parameterization in order to observe the appropriate value for each parameter. So they set a value, they run the benchmark, and then they observe the performance value. They change the parameters value, they run the benchmark again in order to observe the changes. So instead of doing that, we build this kind of experiment that can directly tell the developers how the performance change when you change the parameters value. So we are working on the parameter level, right? Yes, those kind of parameters are the configuration of the benchmark, kind of say, but I don't know the similarity or difference because I didn't follow that talk, unfortunately.
Okay, so thank you everybody for the discussion. It was very interesting. So I think we can go to our last speaker for this session. He is Norbert Smith, a PhD student at the University of Würzburg, whose research focuses on the energy efficiency of cloud data centers. Please, Norbert.
Hi, thank you for the introduction. I will be presenting our industry track paper for the SpecPower Next benchmark suite that is currently under development, and talk a little bit about the new workloads from the perspective of the developers, which are my co-authors, among others. Well, why do we develop new benchmarks, industry standard benchmarks? It's because they drive innovation between vendors, and they create a competitive and fair playing field to increase and to better whatever they are producing and whatever we are measuring with the benchmarks. And on the chance I'm repeating myself here, energy efficiency is really important that we measure with the SpecPower Next benchmark suite, because data centers consume a lot of energy, and it's estimated to rise to about 1 petawatt hour in about 10 years times. So the SpecPower SSJ benchmark, which is the currently still most current benchmark from SpecPower, has achieved a lot. It has over 700 peer-reviewed publicly available results. it achieved a 90-time average energy efficiency increase, and at maximum 113-time energy efficiency increase for single CPU servers, which are the red dots in the white figure that you can see. And so it's clear that, as it is from 2008, it's clear that a new version is in order to further improve energy efficiency among servers. To do that, the new version is under development currently, and it gets new workloads, new modern workloads, which are the wiki workloads, which contains 3 what we call worklets, which are make up the workload, which are 3 different tasks that the workload has to achieve, and a new auxiliary processing accelerator workload, which stresses, as the name suggests, auxiliary processing cards like GPUs. And this comes with 10 worklets. All 10 worklets for the APA workload are implemented in both variants, which are CUDA, which most people know, I assume, and OpenCL. And also SpecPower Next will, among new workloads, also be based on a new framework, which is the Chauffeur WDK framework, which instead of implementing all the tricky stuff in the background, how to measure how the load level should be achieved, all this is now taken care of Chauffeur WDK, which allows the developer to focus really on the workloads instead of all the more surrounding technical stuff. And Chauffeur WDK takes also care of calibration of maximum load, or what is the maximum number of transactions for a given worklet and workload, and then defining load levels at 170, 60%, whatever is set in the configuration, and then takes care that this load level is reached for the system. And it also comes with a standardized way for collecting hardware information from the server, because for repetition you need all the information from the system, what CPU, what operating systems, all this stuff can now be collected in a standardized way, at least the hardware information via Redfish, which gives you all the information in JSON format. Also, this had to be done with self-written implemented scripts that have to be executed on the system. We can see on the 2 figures on the right, the upper figure is from the old SpecPower SSJ benchmark. You have your one workload that stresses CPU and memory. You have your control system, the CCS, that takes care of the load levels, reaching the load levels. Everything has to be self-implemented. And with the new Chauffeur WDK, we now have a RESTful API for Redfish, which gives us the hardware information. We have different worklets which make up a workload, and they can stress a lot more than memory databases, CPU, and auxiliary processing accelerators. And to show you how the SpecPower Next is currently, which state it is, we have done some preliminary measurements. So please keep in mind these measurements are from a current development version, and they might change in the final release. And we can see that in the top figure for the CPU load, that the SpecPower Next is able to stress the CPU to full capacity and even reach dedicated load levels. In this case, it was 100%, 75, 50, and 25%. And you can see these load levels with some variations inside them at the very top among all 3 worklets, which are in yellow, the transformation worklet, just some compression, JSON parsing and stuff. Then you have the natural language processing worklet, also stressing the CPU, and the security worklet doing encryption and decryption.
Norbert, you have 30 seconds.
Okay, thank you. We can also see the load levels for the total file operations and for also in the read operations, but sadly currently not, they're not as present in the file write operations in the 4th figure. And for the memory, in the 2nd figure, we can see that the load levels are also not present, but this is mostly due to the case that this workload was not specifically meant to stress the memory to certain load levels. This is just a side effect and of the synthetic benchmark. So you would need to tune to memory workload specifically to see load levels here, but it still uses the majority of the available memory in the system under test. So thank you for your attention. If you have any question.
Thank you, Norbert. Is there any questions from the audience? Oh, maybe I see a question on the Zoom chat. Maybe you want to read it, Albert?
Yeah, I was just cheating a little bit by typing it ahead of time. So I was just curious, at the first slide you mentioned having an 100x improvement in efficiency, and somehow you said, or at least I understood it was thanks to the benchmark. So could you elaborate on that? Because 100x improvement in efficiency, that would be like great. So how can a benchmark somehow secure that?
Well, it's not that the benchmark itself made the server better. It's just that the developers have sort of make. Oh, sorry, yeah. Oh, Klaus.
So no, actually, Peter, as a vendor, the benchmark, without being able to measure energy efficiency, we would not be able to improve our showcase that our servers are getting better in marketing. And that is actually enabled, maybe he phrased it a little bit funny, but here it is enabled that we can compete and we can improve our servers versus the other competition in the market. And that is the driving factor where spec power drove the energy efficient up over the last, I don't know, 16 years.
Got it. So I was curious if the users of the benchmark somehow give you back feedback on how it helped them, or if it's more of a general statement. So this kind of thing.
I mean, when we inspect, when we develop the benchmarks, there you have a standard mode where you have valid results across the different competition, but you have a lot of features in there for a research mode that we can enable, and then we can seeing certain things, maybe just focusing on the 100%, or maybe just focusing on idle, and improve it. It's not just, yes, we're using it as a benchmark, but we're also having, you can customize a lot of these, the variables, how long and how many stress you put on the system, so that we as a vendor can see, okay, this is now improving because we're focusing on one particular area. On that, and the next generation of servers goes into them, and then we're stressing again.
Thank you.
So every generation improves because of this.
Yeah, thank you.
Sorry, Norbert, go ahead.
No problem. Thank you for answering the question.
We may have time for a last question. Katja, you want to read it?
Yeah, I wanted to ask a bit more on this calibration and what happens in case of fluctuating loads.
I'm sorry, what plots?
So in case of fluctuating loads, what happens for calibration?
Well, the calibration is actually run several times. So you can see the calibration in the darker gray area. It runs, in this case, it was run twice to reach the maximum load. So this is basically, it pushes as much transaction as it can get through the system. And then it takes an average of these two. You could also increase the number of calibration runs to get a better average. And this is then taken as the full load of the system, the 100% load level.
So if I got correctly, it's more on the multiplicity of the time that you are calibrating. So you do not change of how much and the intensities in case of loads that are less stable than others.
Well, it's not that we set an intensity. The intensity that is calibrated is not set in stone. It just gives one transaction after another without pausing, and as soon as 100% load level is reached, then no further transaction are going through. this is 100% load. And this is done several times, and then the average is taken. So there's not much fluctuation here in intensity.
Okay, I see. Okay, thank you.
Okay, so if there are not any other questions, I think this concludes session 6. Thank you everybody for the presentation, the questions, and the discussion. So I think now there is a coffee break till 6:15, and then there will be session 7. Bye everybody.
Hello. I think we are ready to start the next session. I'm going to be the chair of the next session. So I'm just trying to figure out if Thomas is online. Thomas Prato?
Yes, I'm here.
Okay, that means that my sound system works, because I was wondering. Okay. Well, we still have 1 minute, so we'll start then. Are you able to share the screen? Can you check that now?
Okay.
Yeah, okay. Okay, I think we are ready. So good morning, good evening, or good afternoon, depending on where you are. I'm Marin Litoyo from York University, Toronto, Canada, and I'm the chair of this session. We have 5 papers in this session. The session is S7, IoT, Embedded Systems, and Cloud. So we have 5 papers, 4 short papers, and 1 regular paper from industry track. And please use Slack channel to ask questions, and also please use the chat on Zoom to ask questions. I'll try to pick the questions in the order in which they are submitted. For presenters, please stay within the time allocated to you, which is no more than 5 minutes for presentations, because we only have 45 minutes for 5 presentations. So please stay within the time allocated. So with that, we'll start with the first presentation by Thomas Prato. And Thomas is a PhD student at University of Würzburg, and is part of the Security Performance Research Group led by Sam Kunev. Okay, Thomas, you can go.
Okay, thanks for the introduction. Today I want to teaser our paper with the title Towards a Group Encryption Scheme Benchmark, a Few and Centralized Schemes with Focus on IoT. I want to begin my teaser with a short motivation why we have chosen this topic. Therefore, I have the following figure, which shows on the x-axis the years from 2015 to 2025, and on the y-axis the amount of devices connected to the internet in billions. Thereby in red, we can see the amount of IoT devices, and in white, the amount of non-IoT devices. What we can see in this figure is that the proportion of non-IoT and IoT devices is completely changing over the years. So when we look at 2015, we can see that mainly non-IoT devices had been connected to the internet. But when we look to the year 2025, we can see that mainly IoT devices are going to be connected to the internet. This means that the internet of the future is mainly consisting of IoT devices, which is in terms of security a problem, since the security of these devices is not taken into account so far, which can, for example, be seen that 70% of all IoT devices are still communicating unencrypted, and that the lack of IoT security had been exploited in the past in form of botnets, like the Mirari botnet, which performed DDoS attacks. The reason why the security of these devices is not taken into account and why they are still communicating unencrypted is that it's complex to encrypt IoT communication. The reason, therefore, I want to illustrate with the following figure, which shows a smartwatch which monitors our heart rate and forwards this information to our smartphone, to our doctor, or to our healthcare. This example should illustrate that IoT communication is typically one-to-many or many-to-many communication, which is way more complex to encrypt than traditional one-to-one communication. A naive approach would be that the smartwatch encrypts this message for each group, for each recipient individually, which would lead to a lot of computational overhead, which is often not doable for often only resource-constrained, battery-powered IoT device. What we want instead is that the smartwatch can encrypt the message only once in such a way that each recipient of the group can decrypt the message. And the kind of encryption schemes that allow that behavior are called group encryption schemes, and a lot of them had been proposed in the literature. But it's still challenging, difficult for developers to pick the right scheme for the concrete use case, since these schemes are often only analyzed theoretically. So there are no practical performance analysis, especially not for IoT environments. And there's no overview of the requirements of the schemes and the features they offer. Because of these two reasons, it's difficult for developers to pick the right scheme. And to support developers by picking the scheme for their concrete use case, we decided to design a benchmark for centralized group encryption schemes. This focus on IoT, which developer can use to pick the right scheme for their concrete use case. Like traditional benchmarks, our benchmark consists of metrics and workloads and of a measurement setup. Thereby, we have chosen an IoT typical measurements app. And in addition, we also added features and requirements to our benchmark, since we are the opinion that they are also important for the comparison of these schemes. Because of time constraints, I can't present all the components of our benchmark, but I want to quickly teaser the features that we have determined. Therefore, we have conducted a literature review, and we were able to determine 4 features that group encryption scheme can offer, and we plan to extend this list in the future. The 4 features that we identified is first the group size limit. This feature describes if a group member can join groups of arbitrary large sizes. The second one is backward secrecy. This describes if a new group member can read all group messages or not. And the last feature is forward secrecy. This feature describes if an old group member can read new group messages. Or more specific, if a group member, after it had been removed from the group, can decrypt messages which had been encrypted for the group after he has been removed. So far to the short teaser of our paper. I hope I could excite you for our work and to motivate you to read our paper. And now I would be open for questions.
Okay, questions. There are questions on Slack. The first one actually was for me, and I'll read it. So it's very nice work. Can you comment on how do you plan to emulate, or have you already done, to emulate, simulate, test bed the group size in your benchmark, right? Because you need a lot of devices, looks to me. It depends on the domain. It can be quite complicated. How would you plan to work on that?
Yes, first, our benchmark is focused on centralized schemes, so that for conducting measurements, we don't need all group members, but we can have only one group member which performs the computations, and we can do the performance measurements there because we only need one group member and the central instance, because we are focusing only on centralized schemes. And we have taken groups up to 550 members into account. And we have used real hardware for doing these measurements.
I see. And related to that, what is the right group size in these domains? I mean, can be 200. I know you use around 200, but what's the typical group size?
There we try to figure out in the literature which is a typical group size for IoT scenarios. We weren't able to figure it out. At the moment, we have also an industry research project where we hope that we can get to some use case from industry. And we also plan to extend our benchmark in the future for different kinds of group encryption schemes, for example, decentralized or hybrid schemes. And therefore, we want to also include workloads for real-world scenarios. But so far, we have only chosen only the size of 550 group members and have used this number.
Okay, thank you very much, Thomas. I don't see questions on the chat. There are questions on Slack, and you can answer them there. I would like to ask you to move to the next paper, because the next paper is presented by Thomas as well, and it's about performance impact analysis of securing MQTT using TLS.
Okay. Then, thanks for the introduction. Now I want to tease our second paper with the title Performance Impact Analysis of Securing MQTT Using TLS. Again, I first want to quickly motivate our work. And since it's mainly the same motivation as in the last presentation, I only want to quickly summarize it. Again, we have this figure. It shows us that the Internet of the future is mainly consisting of IoT devices, and that these devices are communicating unencrypted, which is a problem in terms of security. In the last paper, we looked at group encryption schemes in order to encrypt this kind of communication. In this paper, we looked at TLS, which we want to use to encrypt this communication. Concrete, we looked at the combination of MQTT, which we secure using TLS. But in contrast to the last presentation, where we use group encryption schemes, we have to make certain assumptions that we can secure MQTT, one of the most commonly used IoT protocols, using TLS. And these assumptions we have to make that we can use TLS, I want to present next. Therefore, I have the following figure, which illustrates typical MQTT communication. We can see in this figure a publisher IoT device who wants to send messages to subscriber IoT device. But since there's no direct connection or communication between the publisher and the subscriber, the publisher has to send its data to the broker, who then forwards this message to the subscribers. In case of MQTT, this kind of communication is unencrypted, so an attacker can simply intercept messages and read them since they are in plain text. When we now want to secure this kind of communication using TLS, this would mean that we encrypt the communication between the publisher and the broker, and between the broker and the subscriber. That way, an attacker can't just simply intercept messages anymore, since they are now encrypted. But in contrast to group encryption schemes, TLS doesn't offer us end-to-end encryption, but only transport layer encryption. This means that the broker can decrypt all messages and therefore knows all messages. And this leads us to the assumption we have to make when we want to use TLS to secure MQTT. And this assumption is that we can trust the broker. And this assumption is sufficient for many use cases, because often when we own and control the IoT devices, we often also control the broker. So this assumption is essential that we can use TLS to secure MQTT. So far to this assumption. In order to be able to analyze now how TLS impacts the performance of IoT devices when we want to secure their communication via MQTT, we had to define an IoT measurement setup. We had to define workloads and metrics in order to be able to perform performance measurements where we measure IoT devices which are communicating via MQTT when they use TLS and when they don't use TLS. Because of time constraints, I can again not present all these components, but I want to quickly tease the metrics that we were using. As metrics, we use throughput, energy efficiency, and the broker connection time. And in order to be able to also take the accuracy of the used measurement equipment into account, we use Gaussian error propagation to take their accuracy into account and look how their errors propagate through the calculation of the matrix. So far to my short teaser. Again, I hope I could excite you for our work and to motivate you reading our paper. And again, I'm open for questions.
Okay, thank you very much, Thomas. I will pick up a question from Slack, where there is a lot of activity. And I'm going to pick the question from Sam Ogden. Can you ask the question?
Sure. I think I had a couple of them.
I know, but is the one on MQTT?
So I was wondering about the overhead of TLS on each of the messages and block cycles. I know you kind of answered that, or block ciphers would add a little bit compared to the payload size you were using. So I was wondering if you had any thoughts about how that might lead to increased energy consumption based on overhead added that way.
So far, we have used only one cipher suite to encrypt the communication. And what we found out in our measurements is that TLS has no provable negative impact on the performance when we have perfect network conditions. but that TLS deteriorate the performance of the MQTT communication when the network conditions deteriorate.
Yeah, I mean, it looked like that was just for like the connection establishment was the big time.
Yes, but also then when we are later on sending messages, then it's also that when the net, so we can say that in our measurements we saw only that the performance get worse when we use TLS when the network conditions were bad. Also when in the case.
Thank you, Thomas. I just want to pick up another question from the chat. Joydeep, can you ask the question?
Sure. So I was just wondering, TLS seems to perform poorly when used for non-optimal network conditions. So can you recommend any alternatives to TLS?
The most simple approach would be that TLS is, for example, also established a key agreement between the communicating parties. What we can do instead is that we put the keys on the device in advance, so that the IoT device can simply encrypt the message and send them with the keys. That way we have less communication between the devices since they don't have agree on keys. But we still have the problem that when the network conditions are bad, that the message doesn't arrive at its destination. But this isn't a problem of the encryption, but it's in general a problem in distributed networks. So the most easiest way to encrypt the communication would be to put the keys on the devices in advance, and let the devices encrypt the messages and send them, and then take care that the message arrive at its destination.
I see. Great. Thank you.
Thank you very much, Thomas. In the interest of time, we have to move on. Thank you. You can answer the other questions on Slack after this. So, okay. Yeah, okay. The next talk is from Vittoriano Motilio, PySlicer, characterizing and dynamically cutting cloud inference response time. Vittoriano, are you?
From me. The next one.
I think it's actually me. I'm Sam. For PySlicer, if that's the next one.
Oh, sorry. Okay.
Yeah, no worries.
Okay, Sam, go ahead.
Sam.
Go ahead.
I'm a PhD candidate at Worcester Polytechnic in Worcester, Massachusetts. Sorry to cut off the intro, but thank you for coming. So the big thing that this work gets into is the idea that mobile devices exist in an inherently mobile environment. And so we should be making decisions on them in a dynamic way. And one way we can do this is we can model each of the interactions that they have and determine what the best path to use is. So in this paper, we make a simple deep learning application to benchmark, model the different steps, and show that we can improve the performance of a deep learning inference application by using simple models. So specifically, we're looking at an image classification application, and we're looking to look at the trade-offs between different choices and how we can make them. We chose an image classification application because to demonstrate this, because there's a lot of active research on these models, and there's a lot of easily measurable data. It's not like voice data where it's harder to get reasonable input data. I can just take pictures of my advisor's dog. So there's a couple of different steps to using this applications, and we really care about these steps in the middle, steps 2 through 4. This is the pre-processing and network transfer step. These are all the steps that occur pre-execution, so we group them into pre-execution time. Basically, these pre-execution steps consist of resizing and cropping the image, which can dramatically decrease the size. So that's why we focus on pre-processing, because it can be done on the mobile device or in the cloud. And these steps can dramatically impact network transfer time, giving us this large potential for trade-offs. Specifically, these trade-offs look like this. We see that we have on-device pre-processing or in-cloud pre-processing. We see that we can do that there's sections where they trade off, where one is faster than the other. So if we do pre-processing on device, it's slower, but it can greatly reduce the network transfer latency. But for smaller images, we can see that the pre-processing adds overhead, but can be better to transfer raw images instead. It's important to note that, like, while on this image, the area that we see is very small, where it looks like it would be advantageous to do in-cloud preprocessing, but that's not always the case. In reality, due to pictures taken on cell phones, this is actually a much more important area because you don't often see a 10 megabyte cell phone image. But our general idea is that we'll model the different paths that can be taken on device or in cloud and use them in an application that we call PySlicer, which is outlined here, and make decisions about whether to preprocess on device or in cloud. Basically, we use models to estimate the latency of each choice, and then we take the choice that has the lower latency. Our goals for these models were obviously to be accurate and low overhead, with the latter being very important since we're running on mobile devices. We tested 5 different kinds of models: SVR, K-nearest neighbors, linear regression, random forest, and lasso, which we picked because those were a pretty good range of the models that people typically use for this sort of thing. In short, we found that linear regression fit our needs the best. It had really good accuracy, when we were considering multiple networks in one model. This was acceptable because we were planning to do a modular approach where each component, each network, and each device has its own set of models. And so to replace one of the models, you can just swap it in. So the question there is, how well does this work? How well does PySlicer perform? We compared PySlicer to a derived baseline that selected the faster of either on device or in cloud for each image. So in parallel to running PySlicer, we then ran at the same time to ensure network conditions were the same image using both on device and in cloud. And we compared against which one of these would have been better to determine our classification accuracy, which we report as an F1 score here, which goes from 0 to 1, with 1 being perfect. We see that in all cases, PySlicer does really well, really close to 1. So we had really high classification accuracy. And also, we did this really fast. These decisions were made on average in 330 microseconds, which great for on-device performance, even on older devices. Real-world savings, this turned out really well as well. We have 2 instances that we're going to look at. The first is our best savings overall, which was a reduction of 16.5%, or 217 milliseconds, compared to our derived baseline. And the other one is the best median performance, which was a savings of 6.6%, or just under 50 milliseconds. So even though we're using these simple models that run really fast, we get this large savings in the pre-execution time. So I hope the paper sounds interesting. I'd be happy to take questions, check it out, and check out the other stuff we do at cake.wpi.edu.
Thank you very much, Sam. Very, very good presentation and very interesting work. I'll pick up a question from Slack. Yar, can you ask your question? Yarov.
Hello, can you hear me?
Yes.
Okay, so the question I asked, and by the way, great presentation, Sam. My question is, can the performance model be created and updated dynamically at runtime? So for example, if there's a change in the cloud or edge server that may affect the latency, could we rebuild a performance model in response to this change? And how long would it take to build a performance model in PySlicer?
Yeah, absolutely. So another advantage of linear regression models is that they're really easy and relatively fast to train. And so I believe you can also do them in online training more easily than other modeling approaches, which means that you could theoretically be updating them continuously as you're collecting new data points. With respect to specifics about how long it trained, with the 51,000 data points that we gathered, it took approximately 600 seconds to train our models on an old laptop. I would expect my new, like an actual cloud server would do much better. And compared to another algorithm, SVM, took, I can't do the math in my head right now. I'm going to go with 8 times longer. No, 80 times longer, because it was 4,200 seconds. 8. Either way, it took much longer. So replacing them is as simple as basically retraining the model when you've collected enough data, or doing it in an online process and then passing it along. But we currently train them offline, so that's something we would want to look into in the future.
Thank you very much, Sam. Again, I hate to have to move on because we only have 45 minutes in total. So there are other questions in the Slack channel, so please answer them there.
Yep, thank you.
Okay, now we move on to Vittoriano. I assume this time I'm correct. Yeah,
Oh, yeah.
Okay.
Hello, I'm
Vittoriano Mutilio, okay.
Okay, sorry, one moment. Okay, I have to disable. Okay, I have some problem.
Hello,
Okay, I have some problem with the
execution and power energy
Sorry.
consumption.
Okay, I will switch not on the presentation mode, but only with the slide. It's the same, don't worry. So thanks for the introduction. I will present this work that is related to some machine learning techniques in order to predict performance of embedded software. So we just want to introduce this approach inside a whole electronic system unit design flow, where we want to analyze different aspects of the performance of the system when we consider different application or different functionality. And we want to predict and to try to just check and find the best solution for our purpose and requirement. So we want to just apply some issues in co-simulation in terms of abstraction level, accuracy, and so on, in order to make some trade-off among different methods. So in our work, we just introduce a method and an approach that just try to use data and measurement in terms of just predict using machine learning techniques, and we just want to replace the execution of the real platform or the execution of some simulator, because this is time consuming. We want to reduce the simulation time in terms of performance estimation. So we are we have a tool that is based on different blocks, and each block is just take some aspect of the machine learning design flow. We just generate some input data that can be randomly generated, or we can fix this data and analyze the distribution of the inputs related to different functions. Then we extract some information that can be statically or dynamically related to the execution of our code. So we extract some information from executing the code on host environment in order to say how many statements and instructions are executing, and then we just extracting dynamic information, executing them on a specific class of processor. Then we just apply our machine learning block, where we just analyze and prepare the data using some features extraction, and then we just try to learn and predict in the right way the performance of the system. We select some machine learning techniques from state of the art, from literature, and then we select also some specific class of processors that are used in embedded domain, that can be aerospace for Leon 3 Spark weight based processor, or Intel 80 Mega 328 or 8051 that are microcontroller used. We just analyze different static and dynamic features, as I said before, and we extract some information related to correlation and also to the possible prediction about them. And some of the machine learning techniques are more suitable for our purpose system to the other one. Considering also the result respect to the test, we have some average percentage error that is lower than 1% for some CISC hardware-based architecture processor, but we have higher error with some different processor architecture that can be risk-based, or that have pipeline, or more complicated one like the Leon 3 that is 32-bit based architecture. Respect to the other work present in literature, we just demonstrate that this approach just reach some good result in terms of average error and also maximum error that we can extract. But we have to refine that, as I said before, respect to different kind of class of processor. We want also to apply this methodology for the hardware prediction. So we want to predict how much latency a software code can have when we just synthesize using relevant synthesis tool, for example. And the training and prediction time is lower, so it's quite good to use this approach in electronic system and also hardware software co-design work. For future work, we want, as I said before, introduce the hardware implementation, increase the number of features, also considering more in detail the input to check which is the best parameter optimization for the model used in this work, or using other machine learning algorithms like neural network or deep neural network, and also apply this approach to other domains, not only embedded software performance, but also, for example, cyber physical system or software computer performance, and so on. Then that's all. If you have some question.
Okay, thank you very much, Vittoriano. There are quite a few questions on Slack. I'll pick up somebody who did not ask a question so far. Thomas Prantl, you have a question for Vittoriano. Can you read it? Or can you ask it again using your microphone?
Yes, he answered me some question on Slack. I just replied on Slack. Like if one.
Oh, you already replied. Ah, okay. You're fast. You're fast. Nevertheless, I mean, not everybody has access to Slack, maybe.
If you want, I don't want, because he just asked me different questions. So maybe I can summarize the question that he just applied to me. He said if it's possible to apply this specific approach to different hardware implementations or hardware processor, and how the input affect the methodology. So all these aspects related to machine learning are under investigation. So we want to increase this work, introducing other aspects that are related to compiler, so optimization flag, to processor, to analyze other kind of architecture that are related to input one. So how many data we have to consider, which kind of benchmark we have to use. Before this session, there was an interesting session for benchmarking. So the shows of the best benchmark function is one of the aspects that we want to analyze, and also which is the best machine learning algorithm that just fit our purpose. If it is based on regression tree, it could be based on neural network, or it's possible to apply other one. So we are analyzing all these aspects, but this is a good starting point for our future work. We have a lot of path to follow in our research.
Okay, thank you very much. Now I found another question that you did not answer to. Jaydeep, can you ask your question?
Sure, yeah. I mean, great work, first of all. I noticed that your ML models take only 10 seconds to train, which I think is considerably lower than the other competing models. And I was just wondering, what's the reason behind this?
It is based on the fact that we just do not consider a dataset that is huge. So we select different function. We select the input. We fix the input generation. So we do not generate a lot of data, but we just analyze first of all how many input data I have to generate in order to extract information at runtime. So we just check, say, if we use bounded input, we can arrive to same output result respect to increase the number of input. There was some statistical analysis on that part. Then after this step, we fix the number of input that that is bounded for this is fixed for every function that we consider. We generate the corresponding data set. So in order to say it, we just prune the inputs in order to reduce the training time. The idea behind this is to just include, because if you increase the data set, you just are able, maybe because it's depends on overfitting problem, to reduce the increase the accuracy, so reduce the error, but we have to increase the training time. So it's something like trade-off that we show, some parameter that we fix in order to arrive to some suitable for our input requirement results. So this is the main thing, because we have a lower training time.
Okay, that sounds like a good trade-off. Thank you.
Okay.
Thank you very much, Vittoriano. Now we move to the next and the last presentation from Yarov. Yar, can you share your screen? Yarov is a PhD student at York University.
Hello, everyone. Can you hear me?
Yes,
okay.
Go ahead.
I'll be doing a 5-minute refresher of our industry paper, Framework for Developing DevOps Operation Automations in Cloud Using Components Off the Shelf. This work was done in collaboration with IBM and their Center for Advanced Studies. So let me begin because we only have 5 minutes. I'll do a quick overview of our motivation and what we're trying to explore. So we look at the domain of multi-cloud platforms. These aggregate multiple cloud providers to achieve faster, easier, and better application building and deployment. In addition, we want to be able to adapt DevOps principles in multi-cloud platforms to ensure good quality of service for cloud applications. As all of you may be aware, DevOps is a popular practice that enables the development team and the operation team to continuously coordinate and collaborate with each other. However, adapting DevOps to multi-cloud environments require a substantial level of automation and adaptation. So we look towards MAPE-K frameworks in an influential control loop model to support the continuous deployment and collaboration found in DevOps. However, there are some challenges within existing MAPE-K frameworks. So industrial MAPE-K frameworks support limited analysis, basic threshold policies, while academia MAPE-K frameworks are less robust and non-scalable. They tend not to be built for production environments. So to get the best of both worlds, our paper explores the feasibility of developing an autonomic MAPE-K framework for multi-cloud platforms by integrating existing services and components off the shelf, COTS for short. So we have 3 main research questions here. The first one, research question 1, is it feasible to build a MAPE-K framework for multi-cloud applications by integrating existing COTS and services? So here we explore the COTS and available industrial services, determine if they meet our requirements. Research question 2, what are the challenges of building such a framework? So this identifies the various tasks needed for integration and challenges that we experience. And research question 3, what is the performance and efficiency of this framework? So this question evaluates the framework on different self-adaptive use cases on an IBM benchmark application. So let me get going. So this is the main components of our proposed framework. So first we have a cloud monitor, which is responsible for the monitoring stage, the state rule engine responsible for the analysis and planning stage, and the workflow engine responsible for the execution stage of the MAPE-K framework. So the cloud monitor collects the metrics of the managed services at runtime and streams them into the state rule engine. It uses service discovery when a new managed service is deployed to automatically start collecting metrics. So this enables continuous automation. And in addition, we can deploy the cloud monitor on multiple cloud platforms to support multi-cloud integration. The state rule engine executes and manages operational rules and enables the DevOps teams to collaborate and maintain the desired level of quality of service at runtime. So the operation team can utilize the rules to manage and deploy the infrastructure and platform for the service at runtime, and the development team can autonomously configure their application as services on the infrastructure at runtime through the rules. And we can also utilize the states of the state rule engine to define the current event of the service to make our decisions. And then finally, we have the workflow engine. So this uses templates, which are the infrastructure details to deploy the managed service. So when a rule is triggered in the state rule engine, it sends a form to apply a new service or modify an existing service, so through the workflow engine. So here we have the concrete architecture of our platform and the components off the shelf we selected for each component. So we use Prometheus for our cloud monitor, Drools for our state rule engine, which collects metrics through the Prometheus API, and then sends the deployment plan to the API of IBM Cloud Automation Manager, which we use as our workflow engine. IBM CAM enables us to manage and deploy services and infrastructure in a multi or hybrid cloud environment. And this process is connected to our own Java components, which we had to write and implement with our own Java code. And here we also provided a table of other COTS that can be potentially used and substituted for each of these components. So because of the time constraint, the implementation challenges are detailed in the paper and in the full presentation on YouTube. So go to the next one. So in our paper, we also implemented and evaluated 3 use cases. And for the use cases, our testbed, we use Acme Air, which is the IBM benchmark application, and MongoDB, and deployed it as containers on 2 different clouds, Savvy Cloud, which is an academic community cloud, and the Amazon EC2 cloud. So in the interest of time, I'm just going to quickly mention just 2 of the use cases. So in the self-configuration use case, we scale the Acme Air containers to keep them within an acceptable threshold, which is described in the Drools rules. So in this figure, we have a sample rule when scaling. So the when statement checks if the state has completed its process, and then it begins to scale here. So it adds an additional container in the JSON description and then sends that through the CAM API. So you can think of this as the when statement is the analysis phase and the then statement is a planning phase. And then in our hybrid use case, we simultaneously scale the Acme Air in a Savvy Cloud and MongoDB in the EC2 cloud, demonstrating our framework working in a multi-cloud hybrid cloud environment. And here you can see the results of the instances being kept within threshold. So when they go beyond the threshold, our Drool rules engine adds an additional instance of MongoDB to the EC2 cloud, and then gets the information of the MongoDB instance, inserts that into the plan for the Acme Air for the Savvy Cloud, and then deploys that. So this is just a very brief 5-minute refresher. The full presentation is available on YouTube, and hopefully this interests you to read the paper as well. So if anyone has any questions, please feel free to ask.
Okay, thank you very much, Yar. I'll pick a question from Slack. Sam, you have a question, right? Can you ask that question? I don't think Yar answered your question.
Yeah, so basically, when I was reading through it, I think you mentioned that one of the biggest issues facing going forward in this work was, I think, the rule engine. And I kind of got the impression that it was because on the one hand, you want a rule engine to be very generalizable, but on the other hand, you also want it to be super specific to an application in a way. And I was just wondering if like this is in fact the case, and like why you picked that out as being like this is what we can improve, what research in the future could improve the most.
Yeah, thanks, Sam. I think I saw your question on Slack, and yeah, I thought it was a great question. So yeah, I think one of the things that you brought up is it can allow developers to also be application specific, right? So this is actually one of the main motivations why we used the Drool engine and the state rule engine, is because first it can be generalizable, and it's very simple when we have like a series of when then rules. And then in the paper, I also mentioned that you can chain these rules, and I provide an example. So one rule can then trigger another rule and so forth. So we're able to make actually complex decisions while using this, kind of very simple rule engine. So at the same time, so it is generalizable, but it allows the developers to describe their application uniquely through the rules. That's why, so it's application specific. And one of the other things that I want to bring up is that we actually have previous papers on this with the rule engine, where we try this on different domains. So we actually have another paper on using this rule engine on the security domain, where we allowed the developers to write their rules specific to their application's security concerns. So we can have application-specific security rules when adding this component. So hopefully that answers the question.
Yep.
Okay, thank you, Yar. You can also reply in more details on Slack. Well, we still have 2 minutes, so time for one more question, I guess, and can be asked by anybody and can be posed for everybody. Any takers on Zoom chat? If not, I'll pick one from the Slack. Jack, you have a question for Sam.
Yeah, so this is the question actually for the previous speakers.
I know.
So,
Now it's for everybody, so that we finished the first round.
yeah, so I guess my question is towards like the prediction models results. The model's prediction results is like great, right? But I'm just wondering, did you kind of actually look at the actual predicted results? If it's just always say predicted to say on device processing or always for in-cloud processing, or the results are actually quite varied depending on the type of device, the data is processed on.
Yeah, so great question. If you go through the paper, we do get on this a little bit, but space constraints and all that. Fairly often, it's recommended to do on-device pre-processing, and that's because networks are slow, and keeping things on device is a more attractive option. However, as soon as you start getting to faster and faster network speeds, it becomes much more appealing to start doing pre-processing or to do pre-processing in the cloud and to transfer the raw data. So one thing we looked at was back of the envelope bandwidth calculation. And when we were doing it on a residential network, we had a bandwidth reduction of something like 98%, because most of the time we do pre-processing on device because my home network is horrible. But on the other hand, as soon as we moved to the school network, which is much faster, we started seeing that it approached, we went up to only 90% reduction in bandwidth, indicating that many more of the raw images were being transferred. So while typically doing it on device is it seems to be a pretty good option, a lot of frameworks such as TensorFlow serving kind of assume that they're getting raw data or that they're getting pre-processed data anyway. Once you start getting faster and faster networks, it does start going much more towards being advantageous to do in-cloud pre-processing and take advantage of the hardware there.
Thank you very much, Sam. So I wish we had another hour to continue our discussions, but we still have the Slack channel to continue the discussions there. So thank you very much, Thomas, Sam, Vittoriano, and Yar for your insightful presentations and work. And thank you, the audience, for asking questions and being interactive. Thank you, organizers, for providing the channel. So with this, we conclude the session, and I pass the control back to the organizers. Okay.
Thank you very much for this last session. So we're now at the end of the conference. So this is the closing time. I think I will keep it as short as possible because everybody is a bit tired with this last very dense few days. So I wanted to take this opportunity to thank everyone again who makes this conference possible, the organization committee and all the chairs, the program committee, the steering committee, all the student volunteers that have actually handled the Zoom very well, the long-time supporter, the sponsor, Huawei this year, which actually make it possible to have free registration. So that's something important to mention at the end also. I want to tell you that most of at least the workshop organizers that came back to me, I've put the recorded video on YouTube, on the YouTube channel, the ICPE YouTube channel, and I've posted the first day of the conference, and we will post the rest of the conference later. One thing that is interesting is that we have 750 members on the Slack channel, so probably it's interesting to continue interacting after the conference with this Slack channel. So it's really amazing. And thank you all for your participation. I will now hand the floor to Andre Bondi that he has an announcement to make, and then we will handle the floor to the organizer of next year conference for the presentation of next year's conference.
Thank you, Joanne. I have served as the WASP
steering committee chair and ICPE steering committee co-chair for the last 9 years. And as I thought it was time for fresh ideas and leadership, I decided to step down, and I wish to commend you to Vittorio Cortellessa, who will succeed me. Vittorio.
Thank you so much, Andre, for your service. You really helped to establish the content and the character of the conference, and it was a lot of work, I know.
Yes, Andre, thanks very much.
And also from the spec side, I can say it has been a great pleasure to work with Andre. And I'm really relieved that he will stay on the steering committee so that we can continue interacting. But he has really played a very important role in this period, and it has been really a great pleasure for me to work with him. So thank you very much, Andre, for all your efforts.
It's been a huge pleasure to work with all of you.
As I already outlined in other occasions, I mean, thank you, Andre, for the great job. Your dedication and your, to this work has been great along the years. So, and you have been one of the founder of this conference. So it has been a pleasure to have you as a steering committee chair. We wish that you could stay more, actually, because but at the end you decided to step out, and I feel honored to be your successor, and I hope to be at least half good as you were. So thank you very much. And as I told in the steering committee meeting, your contribution will be still very valuable in the next years. Thank you very much.
I have every confidence that you will do a wonderful job, Vittorio.
Yes, so welcome, Vittorio. Thanks for accepting.
Thank you. Thank you. I want to thank all the WASP side, let's say, steering committee who has sustained my candidacy. And thank you very much. I will do my best, but thank you, with your help, of course. Thanks.
So I think now we have Arthur Kang and Dan Feng that they will present the next year conference.
Thank you. I'm Arthur Kang, and I'm the local chair of the ICPE 2022 in Beijing. Firstly, I would like to thank the steering committee to allow me to have this chance to serve the ICPE meeting, which is a great honor. As everybody knows, Beijing is the capital city in China. There is also including also the homes, lots of research facilities and universities here. So it will be a wonderful academic meeting here. And we've already decided we will have the meeting in offline and online in both ways. So which means after 2 virtual meetings, we finally get a physical meetings. So it will be a wonderful meeting here, and Beijing welcomes you all. Thank you.
I'm the co-chair of ICPE 2022, Dan Feng from Huazhong University of Science and Technology. I want to say welcome to submit papers and welcome to attend ICPE 2022. Welcome to China next year. Thank you.
So thank you very much for this presentation, and thank you all for participating.
What remains to be said is I want to thank Johan. I suggested him as a candidate to organize this conference. So I hope, Johan, we still have good friendship and you don't have bad feelings for me.
No.
But, you know, it has been a huge challenge, especially with changing from physical to hybrid and then to completely virtual. And I was really feeling bad somehow, feeling sorry how much you have to face these challenges. And thank you so much to you, but also to Jack, of course, as general co-chair, and also to the PC chairs, Vittorio, Corpo, industrial chair, James and Robert, but also to all of the organization committee. A great conference. We are very happy with 466 registered participants, amazing And I'm really happy that the program went well and very nice talks. So thank you very much. We highly appreciate your commitment.
Thank you.
Thank you.
I also would like to thank Joanne for the dedication, and I want to make a wishful thinking that next year we can touch each other, okay, somehow. just to touch and say hi, okay?
Yeah.
And that's probably the best wishful thinking that we could have in this moment, okay?
We have 460 people touching each other.
Yeah, I mean, somehow, at least having the possibility.
Yes.
A big group hug.
Yes.
Yeah. So.
So yeah, I think this concludes this conference. It's hard to shut down.
For next year, looking forward to your submissions.
Yeah.